We're going to take a look at worksheet number 3. We had 4 and 5 for homework. We're going to take a look at number 4 and remind you that if you struggled with number 5, to take a look at it again after we go over number 4, see if it helps. And if it doesn't, then ask me again on Monday about number 5. Number 4 says a 1.5 times 10 to the 3 kilogram car traveling 100 kilometers per hour to the south collides with a 1,200 kilogram car traveling north at 100 kilometers per hour. The heavier car continues to move south, slows to 25. How fast is the lighter car moving after the collision? What do you want to circle here? South, north, south, anything else? Yep. Kilometers per hour? Yeah. I'm going to circle that, but I'm actually going to circle that in a different color. And I'll explain why. If you take a look at your Physics 30 and 13 pages document, we've now finished almost all of topic 15, conservation of momentum. You can see, by the way, there's really only one physics principle that would apply here. It's principle number 4 on the back wall there, conservation of momentum. That's an easy one, right? If you get a question like this and the question says, what physics principle did you use? Principle 4, done. You can see, though, if you look down through the little subtopics of that topic, isolated system, right? No external forces, collision or explosion. We haven't done this explosion yet, but we have done the collision. Okay, explosion comes in the next example. Stick together versus bounce apart. Calculations, units. Wait, any? What? Any units? Yeah, in a conservation of momentum problem, because as long as you're consistent with your units in a problem, because the units will appear in each variable, in each term, the units will cancel. So in this problem, or in any conservation of momentum problem, you can cancel out the units and use whatever ones you want because they cancel. Does that make sense? So we can actually stick with kilometers per hour. We can't for impulse because they don't cancel. We can't for just straight momentum because they don't cancel. But for conservation of momentum, we can stick with, not that one, this one, with kilometers per hour if we want to. Now, if that confuses you, what should you do? Just convert to meters per second, because that's always going to work, right? Now, having said that, if we convert it to meters per second, my final answer will be in meters per second. If I leave it in kilometers per hour, my final answer will be in kilometers per hour. This question didn't specify what the unit should be in, so either would be okay. On a multiple choice and numeric response question, it's going to specify, right? Even if it specifies meters per second, you can leave it in kilometers per hour and convert after, or you can convert to meters per second before you do the question and just do it the way we normally do it with standard units here. Question? No. Okay. So what do you want to do here, guys? Kilometers per hour or meters per second? Meters per second? Okay. That's the way I actually did this. My answer key was in meters per second, so that's what we'll go ahead and do. Just understand that we could have left kilometers per hour. It would have been absolutely fine. By the way, same thing works for mass as well. Could use grams or milligrams, right? Because they appear in every term. So the mass units cancel here as well. All right, let's write down some givens here. Actually, let's identify our cars here first. I'm going to make the lighter car number 1 and heavier car number 2. We talked about that yesterday, right? It doesn't really matter. Like if you want to make the first one number 1 and the second one number 2, whatever. It doesn't matter as long as you're clear on which one is which. I'm going to say M1 is 1,200 kilograms. I'm going to say M2 is 1,500 kilograms. Okay, we got a velocity here that is 100 kilometers per hour to the south. If we divide that by, what's the conversion factor? 3.6. We're going to get 27.777, I think. Yeah. You know what's neat about this, actually? If you forgot what the conversion factor is and thought it was not 3.6 but 4.9, and you forgot that it was divided by 3.6 and you multiplied, so instead of dividing by 3.6, you multiplied by 4.9, guess what? It would actually work because the mistake would cancel out of every term as well. Now, it would work until the very end, okay? if you convert it back to kilometers per hour by dividing by 4.9, right? Your meters per second would be wrong, right? Because they would have been converted wrong throughout the question. But you still could make it work, even if you forgot that conversion factor, because it cancels out. All right, what is this 27.7? Is that positive or negative? That first 27.7 right here. Yeah, that's going to be negative. Good. Is that V1 or is that V2? We're talking about the first one that appears there. V1 or V2, Mason? Yeah, with the way that we've written it here, it's going to be V2. Did you call it V1? Yeah, and that's fine. Okay, you don't need to change that. But with the way we have it written here, it's V2. Is that V2I or V2F? V2I, Ty? Yeah, I, Ty, I. We got another one that's 100 kilometers per hour, or 27.77. Is that second 100 kilometers per hour positive or negative? Yana? Good, because it's north. Okay. Emmerich, it is a velocity. Is it V1 or is it V2? It's the way that I have it expressed here. Good. Is it V1I or is it V1F? Evan, initial or final? 1,500 kilogram car going this speed collides with a 1,200 kilogram car traveling this speed. That's going to be initial, isn't it? The initial velocity of the 1,200 kilogram car, 100 kilometers per hour. Does that make sense? Yeah. The heavier car, which I've defined as mass 2, V2F, the heavier car afterwards moves south at 25. So we're going to make that negative because it's south, and we're going to make it 6.944 meters per second because we're converting to meters per second here. We're looking for the velocity of the lighter car, V1F. Now, somebody in my period 1 class, on one of the questions for homework, I think it was number 5, had a little bit of trouble. He got to this point and said, I remembered everything up until this point, but then I forgot the next equation. And I'm glad he said that, because it enabled me to make a point. And that point is that I don't want you to remember the next equation. I don't want you to remember that. It's different for different questions, right? Pi equals PF is the same no matter what the situation, as long as we're doing a collision or an explosion. But the next part is different. Sometimes it's M1 V1I plus M2 V2I equals M total times VF. Sometimes there's 2 objects afterwards. Sometimes there might be 14 objects afterwards, right? They're all different. So what I want you to do is stop and think at this stage about what comes next and figure it out. Don't remember it. Ask yourself a question. Now, how many objects do we have before this collision takes place? So we're going to have 2 terms then, right? M1 V1I plus M2 V2I. We didn't need to remember that it's M1 V1I plus M2 V2I. We just figure out there's 2 terms, and we're going to have, 2 objects, therefore 2 terms, right? Now, how many objects do we have after the collision takes place? 2. So it's going to be M1 V1F plus M2 V2F. Can we cancel out the mass here? No, we can't. No, the units cancel, right? But the mass itself doesn't, because it's different. So let's sub in our numbers here, unless they're all the same, right? M1 is 1,200 kilograms times V1I is 27.77 plus M2, and this gets kind of long with numbers here, times negative 27.7. Worst part of these questions is writing everything down. V1F is what we're looking for. V2F, or M2 is 1,500 times V2F is negative 6.9994. Whew. Okay, let's haul out this calculator for this one. 1,200 times 27.7778. Let's add to that 1,500 times negative 27.7778. That's the left-hand side, right? Get it? That's my left-hand side. Let's write that down. Negative 8333.364. Now let's figure out this number. If you're good with your calculators, you can do this all in one step, right? But only if you're good with your calculator. Let's say 1,500 times negative 6.94. So negative 10,410. I'm going to take the 10,000 over to the other side. How do I do it? I can subtract the negative, right? Or add positive. I'm going to say negative 8,000. I'll subtract the negative because I already have that number there. Good. Divide that by 1,200. 1.73. Is that what I got? I said 1.74. What did you guys get?
It's supposed to be 6.94.
What did I? Oh, yeah. 6.94444. Yeah. There's a difference between using a rounded number versus a non-rounded number, right? So, yeah, it should work out to be 1.74 meters per second. Good? Is that okay? I think that should make number 5 easier if you struggled a little bit with it. Try it again if you did. And if it doesn't help you a whole lot or you're not able to get it, then ask me on Monday. Community scheduled help or lunchtime on Monday, and we'll take a look at that. Everyone with your hand up? No, good. Okay, let's take a look at another example here right now. This example is, well, if we take a look at that Physics 30 and 13 pages document, we said we hadn't done an explosion. Well, we're about to do one. Yep. This is an explosion. You can see that it says a man stands on ice holding a ball. Man throws the ball goes forward, the man goes backwards. This is not a literal explosion, right? We don't have a bomb blowing up or a firework exploding, whatever. But it's like that, right? A bomb is one piece, and it goes off as several pieces in different directions. This is one thing. The man and the ball are one with each other. And then the man throws the ball. Ball goes one way, man goes the other way. What do we know about the forces involved there? Force of the man on the ball? Yeah, equal and opposite, right? What do we know about the impulses? Equal and opposite, yeah. Impulse on the ball is positive something. The impulse on the man is negative, same thing, right? And we know that momentum is conserved. If the man has negative 10 impulse, the ball has positive 10 impulse, the net impulse is 0, momentum is conserved. When we're solving a collision or an explosion question, first thing we're going to try is that conservation of momentum thing. Analyze the system versus analyzing individual objects. Let's call this one, what do you want to call mass 1? I've been calling the light object number 1. Want to leave that the same?
No, max man.
You just want to make the first one here, mass 1? Okay. Seems to be, David, you and I seem to be outvoted there, so we'll do it that way. Let's say M1 is 75. And let's say M2 is 2.5 kilograms. Man throws the ball forward at 15. So that's a velocity, right? Listen, somebody in the last class said, should we circle forward? We can if you want. I don't find that really helps me, though. I'm not going to get mixed up with signs here because I don't have to enter any negatives into this. I'm going to get a negative answer, but it'll just pop out of the equation. I don't have to make something negative. So I'm not going to worry about drawing attention to that forward. But you can if you want. We're going to make this positive 15. Is it V1 or V2? Is it the velocity of the man or the ball, Bernardo? V2. Is it V2I or V2F? Yeah, it's the final velocity of the ball. We're used to be giving initials, right? This time we're giving a final. We want to find V1F. Is there anything else that we have if we read between the lines here? Evan? Yeah, so does the man, right? We're just going to say VI is equal to 0 meters per second. The man and the ball are together, and they're not moving. So VI is equal to 0. PI is equal to PF. How many objects do we have? Caleb, how many objects do we have before the collision or the explosion takes place? 1. What's its momentum? And Mark, what's the momentum of that one object that's not moving? 0. Why don't we just put in a 0 then? Like, we could put in MVI if we want, but why not just put in 0? If we know, we recognize right away it's at rest. We have 2 objects afterwards, M1, V1F, M2, V2F. Go ahead, sorry.
What's the mass you need to expect?
Nope, because if you did put in M times M to,
0.
right. If this is 0, then anything times 0 is 0. So I'm going to recognize that and just put it in, save myself the bother. Can we cancel out masses here? No, they're different, right? What if they were the same? What if they were both 2.5? The context is a little bit different. It wasn't a man throwing a ball. It was one 2.5 thing goes one way, one 2.5 thing goes the other way. Could we cancel then? Emma, I think I saw you. Yes. Yes. Most people at this point say, no, you couldn't, because it doesn't appear in this term. But if you're, let's say the mass is 2.5. If you divide this term by 2.5 and this term by 2.5, right? You have to divide this term by 2.5. What's 0 divided by 2.5? 0. So if one of the terms is 0, it's fine, right? You can do that. Yeah, if it's the same mass, the only term it doesn't have to appear in is a 0 term. And then you can still cancel it out. But not here, because it's different masses, right? Mass 1 is 75. Mass 1F is what we're looking for, plus mass 2 is 2.5 times mass 2F is 15. Would you expect V1F to be bigger or smaller than V2F? The force is the same. The impulse is the same. Would you expect the velocity to be bigger or smaller? Yeah. Would you expect it to be a little bit smaller or a lot smaller? A lot smaller, because the mass is a lot bigger, right? The impulse is the same. So the momentum gain / loss is the same. If the man has the same momentum as the ball, and he has that much more mass, he must have that much less speed or velocity. Yeah. All right. 2.5 times 15 is 37.5. Take it over to the other side by subtracting. Divide by 75, and we get negative 0.50 meters per second. Good. How is that different than all the questions that we've been doing? Well, not like fundamentally, not at all, right? We just have to look at this question and think when we get to that step of subbing in these equations here. How many objects do we have, and are they moving, and so on? Like it's exactly the same thought process. It's just the implementation is slightly different. Thought process isn't, unless you've memorized, right? Which we don't want to do. Okay, I'd like you to take a look on your worksheet right now at question number 6. See if you can finish that up in the next couple minutes. Worksheet number 6, or sorry, worksheet number 3, question number 6. And then we'll do one more example before the end of class. All right, let's take a look at this Physics 30 and 13 page document again. We've done everything here now, right? Every positive, negative, equation, everything except for 15H, progressive collisions. What is that? Well, that's my name for a collision that's kind of like a domino effect collision. You know what I'm talking about, right? You're sitting at a stop sign, somebody's sitting at the stop sign behind you, and then that third person who's texting doesn't stop, hits the person behind you, who then in turn hits you. So it's like a domino effect, right? I call it a progressive collision because one collision progresses into another collision. It doesn't really matter what we call them, we just need to know how to analyze them. So how do we do that? Well, let's take a look at an example. It says a 1,000 kilogram car traveling north collides with a stationary 1,200 at 10 meters per second. So car number 1 is moving at 10, car number 2 is at rest. Car number 3 Meanwhile, that it should say is also at rest. Doesn't say that, but I meant for that to be the case. Gets hit now. All three cars entangle, they head off together. That's the velocity of this wreckage. Immediately after, like 5 seconds after, it's going to be 0, right? But then we're dealing with external forces. Immediately after, what is it? Well, let's write down some givens. I'm going to say M1 is 1,000. I'm going to say M2 is 1,200. And I'm going to say M3 is 1,200. Something's 10 meters per second. Everything's north, so I'm not going to worry about signs there. What's the 10 meters per second? What V is that? V1, well, this isn't the eye doctors anymore, is it? V1, V2, or V3? What is it? It is V1. Is it V1I or is it V1F? Good, it's V1I. What's V2I? 0. What's V3I? 0. I'm going to write those down as well. V2I is 0, and V3I is 0. And I'm looking for VF, right? The final velocity of this whole wreckage. How am I going to tackle this progressive collision, this domino effect collision? This collision that, well, really two collisions, right? One collision kind of turns into the next one. David, got an idea? Yes, you would. So for the final momentum at the end, mass total is M1 plus M2 plus M3 because they've all stuck together. Absolutely. Yep. You analyze the collision separately? Absolutely, you can do that. So you can say, so what you're saying, I think, is collision 1. Hold on before you write this down, okay, guys? Collision 1, PI is equal to PF. And you would solve for, let's say, VF there, right? Okay, we're not done because we got to analyze collision 2 then, right? We're using PI is equal to PF. This final velocity in collision 1 would become what for collision 2? The initial velocity for collision 2. That make sense? Absolutely. Absolutely that works. Beautiful. But let me just throw this out at you and see which you like better, okay? And I don't care which way you like better. Okay, whatever way you want to do it. This way works absolutely fine. It's just not going to be the way that I'm going to do it to show you right now. Okay? Let's try this. Do you have an idea?
Yeah.
You might be going to say...
The second and third cars are starting at rest. Their initial momentum is 0, so you just calculate the initial momentum for the first car, and then you put it equal to the total mass times the car.
Yeah, it doesn't actually matter if the first two cars, if the other cars are at rest or not, as long as you include them with your initial momentum. Okay, what Bernardo was saying here is essentially what I was going to say, and that is this. If you have two collisions, let's not call it or PI and PF for a second, okay? Because it gets confusing when you have the final from one becoming the initial for the other. Let's call it A and B and C, okay? So let's say in the first collision, PA is equal to PB. Does that make sense? Same as I and F, right? In the second collision, PB is equal to PC. Make sense? Okay, if PA equals PB and PB equals PC, then doesn't PA equal PC? So we don't need to do this as a two collision problem. We can do this as a one collision problem. And it doesn't matter. Bernardo said as long as the second and third car at rest, it doesn't matter. As long as we include their momentum in the initial momentum, it doesn't matter. Right? They could be moving as well at rest this time, but they don't have to be. So that's the way I'm going to do it. But if you're not comfortable with that, do it this way. Do it the way that all of you were thinking before as two separate problems. That's fine. It's just a little bit more work. That's all right. All right, so I'm going to say, I'm going to go back to calling it I and F now, but we're talking initial, like the very beginning of the problem and final, the very end of the problem, and nothing in between. Well, at least what happens in between doesn't matter. There are three objects, M1, V1I, before the collision, plus, why don't we just say 0? Because the second car is at rest, right? And the third car is at rest as well. But Bernardo, if they weren't, we just say M2 V2I plus M3 V3I, right? Equals, David, you said mass total times VF. Absolutely, we got to include that total mass. So M1 is 1,000 times V1I, which is 10, equals, the total mass is 3,400 kilograms times VF. So VF is 10,000 divided by 3,400. Worked out to be like 2 point something, I think it was. 2.94, yeah. 2.94 meters per second. Wow, it seems a lot less messy when we do it as one collision, right? But it's no more right. You are absolutely free to do it my way. Somebody in the last class said, after I said that, spoke up and said, or the highway. No, it's not my way or the highway. Okay, it's my way or any other valid way. Okay, I'm biased. I like my way better. But if you like another way better, do it the other way, as long as it's a valid way to do it. Okay, your homework for the weekend, guys, is practice question set number 4. As well as that, we have worksheet number 3, question number 7.